A portrait painter with no formal science training built the sharpest telescope lenses in human history right in his own backyard. His family went on to break their own world records 5 times in a row, changing everything we know about space. This is the incredible true story of Alvin Clark and Sons telescopes and how they transformed modern astronomy forever. Back in the 1840s, the best telescopes in the world all came from Europe, mainly from German master opticians. America was seen as a scientific backwater where nobody knew how to make serious optical glass or high-quality precision tools. Alvin Clark started out as a successful portrait painter in Massachusetts, known for having super-sharp eyesight and steady hands. One day, his teenage son George tried to melt down an old metal dinner bell to make a small telescope mirror. Alvin saw his son working in the yard and decided to help him out with the messy casting process. That tiny backyard experiment lit an intense fire inside the entire family that never went out for over 50 years. Soon Alvin realized that metal mirrors tarnished way too quickly and lost their ability to reflect clean light. He decided to switch his focus entirely to making refracting telescopes, which use clear glass lenses instead of metal mirrors. He opened a small workshop in Cambridgeport, Massachusetts, bringing in his 2 sons, George Bassett Clark and Alvin Graham Clark. At first, big American universities completely ignored the Clarks because Alvin was just a painter without any fancy physics degrees. To prove his lenses were world-class, Alvin started sending detailed observations of difficult double stars directly to British astronomers. A famous English astronomer named William Rutter Dawes bought several Clark lenses and publicly praised them across all of Europe. Once Europe gave the Clarks their stamp of approval, American scientists suddenly rushed to Cambridgeport to place their own telescope orders. How did a humble American family beat the finest German lens makers at their own game without any computers? The secret weapon was their legendary manual testing method, which opticians now refer to as delicate finger figuring. They would test a giant glass lens with a tiny pinhole of light inside a long, pitch-black basement hallway. If they spotted a microscopic bump on the glass, Alvin would rub it down using just his bare thumb and polishing powder. His fingertips were so sensitive that he could feel and fix glass flaws smaller than the wavelength of visible light. To make these massive lenses, the Clarks had to buy giant blanks of raw crown and flint glass from Europe. Companies like File in France and Chance Brothers in England poured huge discs of pure, bubble-free glass for them. The Clarks paired these pristine optical lenses with rock-solid iron mounts and precision clockwork drives that tracked the moving night sky. By the 1860s, the Clark family was ready to build the biggest refracting telescope the modern world had ever seen. The University of Mississippi ordered an 18.5-inch lens, but the American Civil War suddenly broke out in 1861. The Confederate University could no longer pay for the telescope, so the giant lens stayed behind at the Massachusetts workshop. In January 1862, young Alvin Graham Clark pointed the unfinished 18.5-inch lens toward the night sky. He aimed the telescope right at Sirius, the brightest star visible in our entire northern sky, to test its focus. Suddenly, he saw a tiny point of light dancing right next to the brilliant glare of the primary star. He yelled to his father that he had found a secret companion star that had never been seen before. Astronomers had calculated years earlier that Sirius wobbled, but no telescope on Earth had been sharp enough to actually see why. The Clarks had just discovered Sirius B, the very first white dwarf star ever observed by human eyes. That historic discovery proved beyond any doubt that Clark lenses were the absolute sharpest and most precise optics on the planet. The 18.5-inch lens was quickly sold to the Dearborn Observatory in Chicago, setting off a massive astronomical arms race. Rich American donors and government agencies suddenly wanted to fund the biggest telescopes in existence to claim ultimate bragging rights. In 1873, the Clarks delivered a massive 26-inch refracting telescope to the U.S. Naval Observatory in Washington. At the time, this giant instrument was the largest operational refracting telescope anywhere in the world. Just 4 years later, in 1877, an astronomer named Asaph Hall pointed that 26-inch Clark refractor at Mars. For centuries, astronomers assumed Mars was completely alone as it orbited around the sun. Hall spent long nights straining his eyes against the intense red glare of the planet through the massive glass lens. He discovered 2 tiny moons orbiting Mars, which he named Phobos and Deimos, meaning fear and panic. The discovery sent shockwaves through the global scientific community and proved the unmatched power of American optics once again. The Clarks built an identical 26-inch sister telescope for the Leander McCormick Observatory at the University of Virginia. Soon after, even the Tsar of Imperial Russia came calling, desperate to put Russian astronomy back on the cutting edge. The Clarks built a monstrous 30-inch lens for the Pulkovo Observatory near St. Petersburg in 1885. Tsar Alexander III was so impressed by the stunning view that he awarded Alvin Clark a prestigious gold medal. By the late 1880s, telescope builders realized that smoke and city lights were ruining the best astronomical observations. An eccentric millionaire named James Lick donated a massive fortune to build the world's very first permanent mountaintop observatory. He chose the summit of Mount Hamilton in California, high above the ocean fog and urban dust. The Clark family was chosen to grind and polish a breathtaking 36-inch optical lens for the brand-new Lick Observatory. Transporting that fragile, 3-foot-wide glass disc up a rugged dirt mountain road was a terrifying engineering challenge. When the Lick telescope opened in 1888, it immediately revolutionized how astronomers studied the deep solar system. In 1892, astronomer Edward Emerson Barnard used the 36-inch Lick refractor to spot Jupiter's 5th moon, Amalthea. Amalthea was the first new moon of Jupiter discovered since Galileo Galilei looked through his crude spyglass in 1610. The Clarks were not done yet because one final titanic challenge was waiting for them before the century ended. A wealthy streetcar tycoon named Charles Yerkes offered to fund the ultimate refracting telescope for the University of Chicago. He wanted a lens so enormous that no country on Earth could ever hope to surpass its light-gathering power. The Clarks took on the job to build an unbelievable 40-inch achromatic lens weighing over 500 pounds. Tragedy struck the family during this era as the founding father Alvin died in 1887 at age 83. His son George passed away a few years later in 1891, leaving Alvin Graham to finish the giant project alone. Alvin Graham Clark worked tirelessly in the shop, grinding the 40-inch glass discs to absolute physical perfection. When the Yerkes 40-inch refractor was officially installed in Wisconsin in 1897, it became an instant international wonder. That giant 60-foot-long green tube remains the largest successful refracting telescope ever built for scientific research to this very day. Why did nobody ever build a larger refractor after the Clark family finished the legendary Yerkes 40-inch lens? The answer comes down to basic physics and the inescapable mechanical weight of solid glass optics. A refracting lens can only be supported around its very outer edge, so starlight can pass straight through the middle. When a glass lens gets larger than 40 inches across, gravity makes the center of the heavy glass sag under its own weight. That tiny gravitational sag bends the glass and totally blurs the starlight before it can reach the observer's eyepiece. Large glass lenses also absorb too much incoming light and suffer from slight color fringing called chromatic aberration. Reflecting telescopes with curved mirrors supported from underneath quickly took over as the new kings of deep space astronomy. Alvin Graham Clark died just a few days after testing the giant 40-inch Yerkes lens in 1897. The family business continued operating under new leadership for decades, shifting toward military optics and gun sights during world wars. The historic Clark Optical Company finally closed its doors forever in 1958, ending an era of handcrafted scientific genius. The impact of Alvin Clark and Sons telescopes completely reshaped the landscape of modern astrophysics. They shifted the center of global observational astronomy away from old Europe and directly into the United States. Gilded Age millionaires poured millions of dollars into universities just to house these enormous gleaming brass and iron instruments. Clark telescopes allowed scientists to map the moon, measure the distances to nearby stars, and analyze stellar chemistry through early spectroscopy. Famous astronomer Percival Lowell used a 24-inch Clark refractor in Arizona to study Mars and launch the search for Pluto. Even though giant reflecting mirrors and space telescopes rule astronomy today, classic Clark refractors are still deeply loved. Dozens of original Clark telescopes are still working right now at universities, historic observatories, and public science centers. Amateur stargazers and students still line up on clear nights to look through lenses polished by hand over a century ago. They offer some of the crispest, highest contrast views of the moon and planets that any human eye can possibly experience. An untrained American portrait painter and his sons built a legacy of pure glass that unlocked the secrets of the cosmos.
Thank you for watching. Please like and subscribe. It really helps us.